Hello and welcome to the XD Indexer training from Ormex Systems. This video will teach you how to assign functions to physical inputs and outputs on the drive. In this video, I will cover the I/O section of the project tree. The I/O branch summarizes I/O settings and physical pin assignments. The digital inputs and digital outputs branches are where you make your I/O function assignments. The analog input branch allows you to set a filter time constant on the analog input of the drive. Let's start by looking at the Digital Inputs branch. In this part of the window, you can see inputs 1 through 14 listed. For each physical input, there can be up to 2 input functions. Each input function has a trigger type. For instance, the enable input function is level sensitive, which is denoted by this symbol here. That means that when input 1 is high, the drive will be enabled. It will stay enabled until input 1 goes low. Initiate motion 0 is rising edge triggered, denoted by this symbol. That means to initiate motion 0, input 2 must go from low to high. This also means that if input 2 goes low after motion is triggered, motion will continue until it is complete. For each input, there's a debounce setting in milliseconds. If you know that there may be chatter in the electrical connection on a particular input, increasing the debounce time will eliminate the possibility of accidentally triggering an input multiple times. To make I/O assignments, find the function you are looking for in the list and simply drag it onto the input. To save inputs, you may want to combine 2 functions onto one input. For instance, you may have a programmable limit switch turn on an output in a specific position window. When you are jogging the axis, you may not want this PLS to trigger the output, so you simply drag the PLS inhibit over the jog forward and hesitate for a moment. The input assignment will expand and you can drop PLS inhibit right below jog forward. When input 7 turns on, the axis will jog forward while at the same time the PLS will be disabled. I will add this function to input 8 as well so that the PLS will not operate while jogging in reverse. To remove an input function, right-click and select Remove, or select Remove All Assignments to delete them all. You can also drag unwanted assignments to the trash can. While most of the input functions are self-explanatory, let's take a moment to review a couple that are worth noting. The initiate motion 0 through 7 are the easiest way to trigger up to 8 different motions from the use of one physical input at a time. The XD Indexer has 32 available motions, so to execute motions above motion 7, you will need to use binary coded decimal or BCD inputs. Let's take a quick look at what BCD select is. The XD Indexer can use up to 5 inputs as binary code for any motion from 0 to 31. Let's use these LEDs to represent 5 different inputs on the XD Indexer. If we assign motion BCD select 0 through 4 to them, the XD Indexer can convert a binary code to decimal number. 5 binary inputs can describe decimal numbers from 0 to 31. If all of them are off, the decimal equivalent is 0. If only BCD select 0 is on, the decimal equivalent is 1. If only BCD select 1 is on, the decimal equivalent is 2. If BCD select 0 and 1 are on, the decimal equivalent is 3, and so on. This standard binary conversion can be used to describe any integer from 0 to 31. Also, if you have only 16 motions, you can get away with only using 4 of the 5 input functions. If you did this, you will only be able to trigger motion 0 through 15. Back in the Digital Inputs branch, we can assign motion BCD select functions to several inputs. This last element required to trigger motion is the initiate motion function. I will assign motion BCD select 0 through 3 to inputs 10 through 13 and assign initiate motion BCD selection on input 14. I can now trigger motion 0 through 15 by setting the binary code on inputs 10 through 13 to the desired decimal equivalent or motion number, then trigger the motion by turning input 14 on. Without rehoming the axis, the motor position can be reset to 0 by using Set Position to 0. Stop motion brings the axis to a controlled stop without causing an alarm or fault, after which the axis is ready to execute motion. Sync Condition 1 through 3 are used to trigger the end of a motion or to advance to the next motion in a chain. This is shown in the programming motion video. 2 different torque limits can be invoked to temporarily limit the power of the motor. These limits are level sensitive, so the limit on torque will cease when the input goes off. Refer to the help system for more information about any input function. Next, the Digital Outputs branch allows you to make your output assignments in the same drag and drop manner in which you made input assignments. You also have the option of some rudimentary logic by combining two output functions on the same output. For example, there are two output functions that are related to overtravel limits. You can assign the forward limit to output 6 and the reverse limit to output 7 like this. It may be that your PLC program does not discriminate between forward and reverse overtravels. In this case, you can simplify wiring and programming and save an output on the indexer by combining both functions on output 6 and setting the logic condition to OR. Now, if the forward limit or the reverse limit are reached, the output will turn on. Keep in mind that only two functions can be assigned to an output, and you can use logic operators OR, AND, OR NOT, and NOT. Note that on the far right you can see that outputs 1 through 6 have a 100 milliamp maximum current output, and that outputs 7 and 8 have up to 1 amp capacity. Again, the output functions are pretty self-explanatory, but I will go over a couple of them here. All of the functions labeled input 1 through 14 allow you to simply pass the status of one of the physical inputs through to an output. If I assign input 1 to output 8, when input 1 turns on, output 8 will follow suit. Output pulse 1 through 3 are pulsed outputs triggered from the motion table. They can be used to specify an event with a very specific behavior. The motion programming video reviews how to use these output pulses in your program. Finally, let's go back up to the I/O main branch in the project tree. This branch summarizes each pin of the 37-pin I/O connector on the XD indexer. You can send this cheat sheet to the printer as simple documentation for faster system commissioning or as part of the machine documentation. The physical I/O on the indexer is very flexible. It can be wired as syncing or sourcing or mixed. For more information about how to wire I/O, refer to the Quick Start Guide, Product Manual, or Help System in Motion Set. This concludes this instructional video. For more information about how to use the XD indexer, visit us at ormac.com.